Okay, so this is systems of inequalities. And it's section 9.9. All right, so steps to doing this. Number one, graph like it's an equation, dashed if not equal to, solid if it is equal to. Okay. Then you're going to pick test points. And I usually pick 0, 0 if it's not on my equation. Plug into equations and determine if it's true or false for the inequality, and then shade region which makes all of your inequalities true. Okay, so I'm going to work 3 examples for you. Example number 1, we're going to have y is greater than x minus 2 squared plus 4, and y is less than, it should be equal to, 2x plus 3. Okay, so this is a parabola with a vertex at 3, 4. Excuse me, 2, 4. And this is a line. The slope equals 2, y-intercept is 3. So first thing I'm going to do is graph this guy. All right. So I've got a parabola with vertexes at 2, 4, 1, 1, so it's going to be opening up like this. Okay. Got a y-intercept at 3. Slope will be 2, up 2 over 1. It's going to be looking like this. Okay, so what I'm going to do is start with my parabola. And this, by the way, the line should be dashed. Because it's not equal to, so my line should be dashed. And parabola is solid. Okay. We'll start with my parabola. I'm going to pick a point 0, 0 and plug it in. So that would mean then that 0, this is what we're trying to figure out, is that less than or equal to 0 minus 2 plus 4? So 0 greater than or equal to 4 plus 4, and that's false. So since this doesn't work, the area I need to shade on my parabola is going to be the inside part. And then I'm going to do the same point for the line. So it would be 0 is less than 2 times 0 plus 3. So is 0 less than 3, and the answer is true. So I'm going to take this part of y. And if you'll notice, the area where the two of them intersect is this area right here. And this is your solution. Okay. Let's do another one. X plus 2y is less than or equal to 14. 3x minus y is greater than or equal to 0. And x minus y is greater than or equal to 2. Now the first thing you notice is these are all lines in standard form. So the best thing to do is to graph using x and y intercepts. Your x-intercept is where y is 0. Y-intercept is where x is 0. So on the first one, if I put y is 0, I'm going to end up with x equals to 14. That's my x-intercept. And then if my x is 0, I'm going to end up with 2y is 14 or y is 7. So I'm going to do these in groups of 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 4, 6, 8. So my x-intercept on this first one was 14, 2, 4, 6, 8, 10, 12, 14. My y-intercept is 7, 2, 4, 6, 7. It's an equal to, so it's going to be solid, and I just connect these 2 points with a line. Okay, again, 0, 0 is not out here, so I'm going to check this guy. So I'm going to have 0 plus 0. Is that less than or equal to 14? The answer is true. So the area on this one is going to be below it. It's the area that contains 0, 0. Okay, now I'm going to plot this guy. Okay, now this one, you can't do x and y intercepts because you're going to end up with 0. Okay, so what I'm going to do is rewrite this one into y equals mx plus b, which is going to give me, that should be, y equals 3x. So I've got an x-intercept of 0, y-intercept of 0, and slope of 3, so I go 2, 3, and over 1. So this guy looks like this. Now I can't pick 0, 0 on this because it's on my line. So instead I'm going to pick 1, 1. Or I'm going to pick 1, 0, excuse me, this point right here. So I'm going to plug it in, so I'm going to have 3 minus 0. Is that greater than 0? The answer is that that one is true. So the point containing, the side containing that, which is this one, is what's going to be my solution area. And now I've got one more to do. This guy right here. So for my x-intercept y is 0, I'd have x equals 2. Y-intercept, I'd have y equals negative 2. So this point looks like, or this line looks like this. And these are all solid because they're all equal to. And again, I'm going to pick a point 0, 0. So I'll have 0 minus 0 greater than or equal to 2. That's false. So the area I'm looking for is going to be over here. Wait, I did something wrong. My y-intercept is a negative 2. I knew there was something wrong. So this guy's going to look like this. And I picked, and in that case I can't pick 1, 1 anymore. So I picked 1, 1, plugged it in, and it turns out it was true. So this one's going to lie on this side. You notice it's got to be below this one, to the left of this one, to the right of this one. So the area I'm interested in, our solution, is this guy right here. Okay, one more. So we're going to have x is bigger than or equal to 0. Y is bigger than or equal to 0. So all these two tell you is that I'm dealing in the first quadrant. X and Y are both bigger than or equal to 0. Alright, so then I've got a line x is less than or equal to 5, and x plus y is less than or equal to 7. So the first thing I'm going to do then is draw my coordinate axis. So first thing I'm going to do is graph this one. This is a line. It's a vertical line at x equals to 5. So it's this way. And I want where x is less than or equal to 5, so that will be on this side right here. Now, I know I'm in the first quadrant, so I'm also going to have to be over here. So now I do this one, and again I deal with my x and y intercept. So my x-intercept is 7. My y-intercept is also 7. So I come over and I plot my points. 7. I graph these guys. And I pick the point 0, 0. So 0 less than or equal to 7, it's true. So this one is on this side. And as you can see then, the area we're interested in then is going to be on the left of this, above this, to the right of this, and below this. So this is our area of interest. And this is how you solve these systems of inequalities.